Hey guys, welcome back to my channel. Today we're going to do questions on measures. This includes questions on average speed, finding the density, mass, volume, or pressure, force, and area. It will be a mixture of questions from IGCSE Edexcel Maths A, both H and HR. And we'll be doing questions of all difficulty levels that comes in the past papers. So without further delay, let's start the questions. So the first type of question you can get is that they can ask you to change the speed from one metric unit to another. So it says that change the speed of 72 kilometers per hour to a speed in meter per second. So what you need to know is that 1 kilometer is 1,000 meters. 1 hour is 60 minutes. 1 minute is 60 seconds. And 1 hour in seconds is going to be 60 times 60, which is 3,600 seconds. These are the conversions that you need to be familiar with. So we're going from kilometers to meters. So if we're going from kilometers to meters, that means you times it by 1,000. And since it's kilometers per hour, per means division. So that means we're divided by 1 hour is converted into seconds. So that's 3,600 seconds. So cancel the zeros out. That's 720 divided by 36. And that is going to give us 20 meter per second. So that's how you convert the speed from kilometers per hour to meter per second. Then the next type of question you can get is on pressure. So it says a box is put on a table. The face of the box in contact with the table is in the shape of a rectangle, which is 2 meters by 1.25 meters. The pressure on the table due to the box is 42 newtons per meter square. We need to work out the force exerted by the box on the table. So they've already given you the formula in the question, and they will give you the question in most of the cases. In the pressure equals to force over area, the formula is always given. For density equals to mass over volume, sometimes it's given, sometimes it's not. So we have the pressure, which is 42. We need to find the force. And for the area, we just do 2 times 1.25, which are the dimensions of the rectangular box. So 2 times 1.25, that's 2.5. Then 42 times 2.5, that's 105. 105 newtons is the force exerted by the box on the table. Then the next type of question you can get is that Abelai flew by plane from Dubai to Rome. The flight time was 6 hours 42 minutes. The average speed of the plane was 650 kilometers per hour. We have to work out the distance the plane flew. Average speed has the formula of distance divided by time. Average speed is given as 650 kilometers per hour. Distance is what we're trying to find. Time is given in hours and minutes. Since the speed is just in hours, so we need to convert the 42 minutes into hours as well. So since 1 hour is 60 minutes, 1 minute is going to be 1 over 60 hours. So to convert the 42 minutes, we will divide 42 by 60, and that equals 0.7 hours. So it's going to be 6 plus 0.7, which is 6.7. Now we multiply 650 by 6.7 to find the distance, which equals to 4,355 kilometers. That is how you use this formula to find the distance. So remember, convert the minutes into hours first. And to convert minutes into hours, you have to divide the minutes by 60. If it was from hours to minutes, then you times by 60. Now, this question is very similar to the first question that we did, but now the only difference over here is that we're going from meter per second to kilometers per hour, going from a small unit to a bigger unit. So 1 meter is 1/1000 kilometers, and 1 second is 1/3600 hours. So to convert 22 meters into kilometers, first we divide it by 1000. And as we discussed previously, per means division as well. So divided by seconds into hours is going to be 1/3600. Now, if you remember, when we're dividing fractions, we change the division to multiplication and flip the second fraction. So we do the same over here. 22/1000 times 3600 now. So that's 22 times 36/10. I again cancel out the two zeros. So 22 times 36 divided by 10 is 79.2 kilometers per hour. Now, if you compare this with the first one, if you recall, what we did was we times 1000 with the given value and divided it by 3600. Over here, we did the opposite. We divided it by 1000 but times it by 3600. So you can remember it with this way as well. From kilometers to meters, it's times 1000. For meters to kilometers, it's divided by 1000. Then from when you were going from hours to seconds, we were dividing it by 3600. But over here, when you're going from seconds to hours, it's times by 3600. But the reason behind is that the per means division. So meters per second. So meters divided by time, distance divided by time. So you have to remember that distinction. That is easily going to help you in solving these questions. Now, the next question says that pressure equals to force over area again. A box in the shape of a cuboid is going to be put on a table. The whole of one face of the box will be in contact with the table. The force exerted by the box on the table is always 105 newtons. The box is 5 by 4 by 3. The greatest pressure exerted by the box on the table is P newtons per meter square. The least pressure exerted by the box on table is Q newtons per meter square. We have to work out the value of P minus Q. Okay, so this is slightly more difficult, but the main concept is still the same. So when they talk about the greatest pressure, pressure is force over area. To have the greatest value for pressure, that means force has to be bigger and area has to be small. And for the least pressure, I'm going to put this as Q. It's going to be the opposite. Area is big and force is small. So now we know that the force exerted is exactly the same for all, faces. But it's the area that's different. For the greatest pressure, we have to find the smallest area. Smallest area is going to be 4 times 3. So P is going to be 105 divided by 4 times 3. Because 4 times 3 is 12, 5 times 3 is 15, and 4 times 5 is 20. So least value is 4 times 3. And for Q, we need the biggest area. So that's going to be 5 times 4. So that's 105 divided by 12. That's 105 divided by 20. That's going to be 8.75. And this one is going to be 5.25. So now P minus Q equals to 8.75 minus 5.25, which equals to 3.5 newtons per meter square. That is your final answer. Then this one says Pedro drove from Toulouse to Montpellier in 2 hours and 42 minutes. He drove at an average speed of 90 kilometers per hour. Janine drove from Toulouse to Montpellier along the same route as Pedro, and the journey took her 3 hours. We need to work out Janine's average speed for the journey. So first, we'll use Pedro's data to find the distance because If it's the same route, that means the distance is going to be the same. So we know speed is distance over time. So that's 90 equals to d over, again, we have to convert the 42 minutes into hours because kilometers per hour for the speed. So 42 divided by 60, which is 0.7 hours. So that's going to be 2.7 because 2 plus 0.7 is 2.7. The 90 times 2.7 is the distance, which is 243 kilometers. Now to find the average speed, we do 243 divided by 3, which is 81 kilometers per hour, and that is your answer. Then another type of question you can get is for density. It says that platinum nuggets are in the shape of a solid cylinder. The radius of each cylinder is 2.5 centimeters. The length of each cylinder is 15 centimeters. The density of platinum is 21.5 grams per centimeter cube. The greatest mass that trackers can carry is 30 kg. Can trackers carry 5 platinum nuggets at the same time? You must show all your weight. So first, we need to know that density equals to mass over volume. We have the density, we don't have the mass, but we can find the volume using these values. So volume of a cylinder is pi r square h. Pi times 2.5 squared times 15. That gives us 294.52 centimeter cube. Now we can find the mass of one nugget. So that's going to be 21.5 equals to m over 294.5. 21.5 times 294.5 equals to m. That's going to be 6331.75 grams. I have to be very careful about the units. Now, the greatest mass that he can carry is 30 kgs. We need to find, can he carry 5 platinum nuggets at the same time? So we can convert the 30 kgs into grams. So that's going to be 30 times 1000 because 1 kg is 1000 grams. So that's 30,000 grams. So for the number of platinum nuggets, that's going to be 30,000 divided by 6,331.75. So let's see what we get. That gives us 4.73, which rounds up to 4 because we cannot round up because he cannot carry, 4 nuggets and then 0.73 nuggets. He can only carry 4 nuggets. So can he carry 5 platinum nuggets at the same time? No, because he can only carry 4. Then the next one, it says that Pablo made a solid gold statue. He melted down some gold blocks and used the gold to make the statue. Each block of gold was a cuboid as shown below. The mass of the statue is 5.73 kgs. The density of gold is 19.32 grams per centimeter cube. We have to work out the least number of gold blocks Pablo melted down in order to make the statue. Show your working clearly. So let's begin with finding the volume of the gold bar. It's going to be 1.5 times 2 times 8. That's 24 centimeter cube. Then we can find the mass of each bar. So we know the density, that's 19.32 equals to mass over 24. So 19.32 times 24 gives us the mass of each gold bar. That's 463.68 grams. Now, the mass of the statue is 5.73. So to work out how many gold blocks were used, and especially the least number of gold blocks, we need to convert the 5.73 into grams first, like we did in the previous question. So in grams, that's going to be 5.73 times 1,000, which is 5730 grams. For the number of gold blocks, we will divide the weight of the statue by that of the block. That's 12.36. Least number, so that's going to be 12. That is the least number of gold blocks Pablo melted down in order to make the statue. Then in this one, it says that the diagram shows a box in the shape of a cuboid. The box is put on a table. The face of the box in contact with the table has length 1.2 meters and width x meters. The force exerted by the box on the table is 27 newtons and the pressure is 30 newtons per meter square. We have to work out the value of x. Very similar to the questions we have done. So pressure is 30, force is 27. The area in contact is 1.2 by x, so 1.2 times x. It's a very easy 3 marks, honestly. We cross multiply 30 times 1.2 times x equals to 27. 30 times 1.2 is going to be 36 times x equals to 27. And x is going to be 27 divided by 36, which is going to give us 0.75 meters as the value of x. And that's your answer. Then this one, it says the diagram shows a solid cylinder made from iron. The cylinder has a diameter of 18 centimeters and height of 3.5 centimeters. The mass of the cylinder is 7.04 kilograms. Work out the density of the iron, give your answer in grams per centimeter cubes. Correct the two significant figures. So first thing you know, for density, we need to find the mass and volume. Mass is given in kgs. They want the density in grams per centimeter cube. So we convert the kgs into grams. So in grams, that's going to be 7.04 times 1,000. That's 7,040 grams. Now for the volume, we know the formula is pi r square h. If you notice, they've given us the diameter, not the radius. Now radius is half of the diameter, which means it's 18 divided by 2, which is 9 centimeters. So pi times 9 square times 3.5, which is going to give us 890.64 centimeter cube. So for density, it's going to be 7,040 divided by 890.64, which gives us 7.9 grams per centimeter cube. That's correct to two significant figures as mentioned in the question. This question says that change the speed of x kilometers per hour into speed in meters per second. So same thing as we done previously, but the only difference is now they're asking us to change a variable into meters per second. So we first times by 1,000 because 1 kilometer is 1,000 meters and we know per is division, so divided by 1 hour is 3,600 seconds. So that's 10x over 36, simplify it, which is going to be 5x over 80. That is your simplified answer. Then this one, it says a solid metal sphere has a radius of 1.5 centimeters. The mass of the sphere is 109.6 grams. We have to work out the density of the sphere. Give the answer correct to three significant figures. So volume of a sphere is 4 over 3 pi r cube. So that's 4 over 3 pi times 1.5 cube. You need to remember that as the shape changes, the formula for the volume would also change. So 1.5 cube times pi times 4 divided by 3 is 14.137 centimeter cube. So for density, we know the formula is mass over volume. So that's 109.6 divided by 14.137, which is going to give us 7.75 grams per centimeter cube as your density. And with that, we're done with the questions for measures. These are the different type of questions you can get. If you have any questions or confusions regarding these, please leave a comment below and I'll help you out. And if you're someone who completely understood everything, please like and subscribe and share this video with your friends.